Okay, welcome back to Calculus 2. Today we are going to talk about volumes of a solid of revolution. So here is the idea, is that we're going to sit here, we're going to get some kind of a value here, right? Say it's just like a line y equals 1 or something. And what we're going to go from 0 to 1 or 0 to h, we can do it that way. Now what we're going to do is we're going to revolve this line about some kind of an axis. That will tell you what it is in the problem. In this case, we're going to say the y-axis. So the idea here is that we're going to sit here and we're going to get this volume of revolution. So really what we're trying to do is we're trying to get this radius and we're revolving it around this axis. And if you remember the volume of a cylinder, right, volume of a cylinder is equal to pi r squared h. Okay. And we're going to pretty much import this idea to do this for like a more generalized idea of a volume of a cylinder here. So this h here, what we're doing is we're saying we're going to take all of these little dx's, okay, all of these little dx pieces here, these little delta x's before I take my limit, okay, and we're going to add all of them up. And really, what we mean by add all of them up, we're adding up all of these pieces, and they're infinitely small, so we have to use an integral. Okay, so instead of doing a sum of delta x's, we're going to be doing an integral of dx's. And the idea here is we're going to do a pi. Remember, we can slide the constants outside of the integral sign. Okay. And we're going to have our r squared, and then our h's are going to be this dx that we're going to add all the way up. Okay. So the volume that we're going to be looking for, the formula we're going to use here is going to be volume is equal to pi integral from a to b of r squared, which in this case is going to be f of x. Okay. Now, we don't have to always revolve around the x-axis. Sometimes we'll revolve around the y-axis. So we're going to say this is going to be f of x. All right, I'll put little brackets there, squared dx, and we're trying to go ahead and integrate through all of that. Now, if we're going to be integrating with respect to y, maybe we're going to revolve around the y-axis and say we're going to do something like this. What we're going to do is we're going to take all of this, and you see how the radiuses that I'm drawing here, those little lines here I'm drawing, are perpendicular to where I'm rotating. In this case, these guys are going to be dy's. I would need an f of y in order to figure out the radiuses for this piece. Okay, so a lot of times we ask you to draw the picture and see what's going on so that you can tell, okay, what exactly are you trying to integrate? What exactly are you trying to figure this thing out? But I think the best thing to do at this point is why don't we do a couple of example problems and we'll see where we are with that. Okay. So one of the problems I have here is we're going to take the function y equals x plus 1. Um, let's go from, we're going to revolve around the x-axis, okay, from x equals 0 to x equals 2. Right? And we're just going to see if we can't get a volume for that. So I'm going to go ahead and graph this thing. So we have our axis here. Okay, I'm going to do one more thing and see if I can. There we go. Jump this up a little bit. So we have our lines. Right? Here's our x, here's our y. When x equals 0, right, we're going to say y is equal to 1. So here's my point. When x equals 1, we have 1 plus 1 is 2, so we can go ahead and plug in 2 here. When x equals 2, we can plug in 2 plus 1 is equal to 3. So we're going to be up here. So really what we got is this piece here. Pretend that's straight. Okay, we could make that straighter, I think. Okay, but we're going to have this. Here's my y value. Here's my radius. And what we're doing is we're revolving it around the x-axis. So what I'm looking for is some kind of a thing that looks like this. Okay, if I look at this piece over here. So it kind of looks like a cup, right? Because it's got a flat bottom and it's got this little thing here. Technically, this thing is called a frustrum. Okay, so it's a frustrum on a cone, but we're going to try to figure out the area that this thing encapsulates. So we could be making cups, and we want to know, like, okay, what's the volume of water this cup would hold? Okay, so we're going to say, okay, our V is equal to integral from What is our A and our B? Well, our A and our B is going to go from x equals 0 to x equals 2. So we're going to go from 0 to 2. We have x plus 1 squared dx, and we have a pi out in front here. And that's going to be my value here. So let's go ahead and deal with this. Now, we have to go ahead and figure out what's going on here. There's a number of ways we can integrate this, but I'm going to do this the easy way, right? So we're going to say pi, here we go, from 0 to 2. And all I'm going to do is multiply this out. And that's just going to be x squared plus 2x plus 1. All I did here was I said x plus 1. Let's go with x plus 1 times x plus 1. I just FOILed this out. So we end up with an x squared. We have an x. We have another x. We have an x plus a 1. So we have x squared plus 2x plus 1. That's all I did. I just did it quickly. Okay. We're still in here with our dx's, and now we're ready to integrate. So going back to the regular easy power rule, so we can just say v equals, we have pi, and what we're going to have here is we have a 1/3 x cubed plus a 2x squared over 2 plus x, and we're going to go from 0 to 2, right? So that's what we're going to do here. So we could say this is going to be v equals, we have our pi. Okay, I've got 2 cubed is going to be 8. So I've got 8/3 here, plus my 2 over 2 cancels. So we have 2 over 2 cancels. So we have 2 squared is 4. And then we have plug in 2 for my x, so plus 2. Minus, okay, if I plug in zeros, we get 0. Okay, that's always a nice thing to do. So we've got, that's the calculation we have to go ahead and deal with. So here we have pi. We've got 8/3 plus 6. I'm going to go ahead and call this 18/3. So we can say this is 8/3 plus 18/3. This is all times pi. 18 plus 8, I think that's going to look like a 26 pi over 3. And that is my volume that I'm looking for here. All right. And that's kind of the way you do these types of problems. It's not too bad. All right. Let's see here. We have another problem. So let's try this one. Okay, so this problem says we want to calculate the volume of revolution. Okay, calculate the volume of revolution. Okay, constrained by, so we're going to say y is equal to x squared and y is equal to 4x. About the y-axis, okay, that'll change soon, about the y-axis. Okay, and then, I'm sorry, we're going to say about the x-axis still. We're still looking at the x-axis. Okay, so about the x-axis. And we're going to go from x equals 0 to x equals 2. Okay, we'll go from 0 to 2. X equals 0 to x equals 2. All of these pieces are going to be given to you in the problem. Okay, that's what we're supposed to do with all of this stuff here. So let's go ahead and we'll draw it and then we'll see what's going on here. Okay, actually it goes from x equals 0 to x equals, actually they're not going to tell us this. Okay, we have to figure it out. So we have to figure out like where is this, where are these curves constrained by? Like where do they meet? Okay, so the first thing we really have to do is figure out like, well, where is x squared equal to 4x? And we can go ahead and figure that out. So we're going to say we have x squared minus 4x is equal to 0. Let's factor out an x. We have x minus 4 equals 0. So we'll have x equals 0 or x equals 4. Okay, so it's going to go from 0 to 4. All right, let's go ahead and have a look at what this graph is going to look like. All right, so we have our x squared. Okay, and I know that x squared is going to look something like this. 1, 2, 3, 4. Okay, and then we have 4x, okay, which is just going to be a straight line. And this is straight. So what's going to happen is we're looking at this huge bowl here, like with this little ice cream cone piece sucked out of it. Okay. So that's what's happening here. So we're getting this whole piece here with this little wedge taken out of it. Okay, so it looks like this big thing over here minus this little hole under here. Okay, and that's what we're trying to graph here. It's important to know which one is the top function and which one is the bottom function because we want top minus bottom when we do this. pick any point between the two intersection points. Like pick when x equals, say, 2, what's going on with my two different pieces here? So we have x squared, 2 squared is going to be 4. We have 4 times 2, we have 8. So the line is bigger than the parabola at x equals 2. It's not going to change until you get to an intersection point, between 0 or 4. So I know that the line is a little bit bigger. So again, we're going to say, okay, we know which one's biggest. So we're going to be able to say we need to integrate between 0 and 4. And what we're going to do is we're going to take our 4x squared minus our x squared multiplied by pi. Okay, because we're taking big volume minus little volume that we're kind of drilling out of this thing. And we're going to take that with respect to x, and we'll go ahead and integrate this piece here. So we have to do a little bit of algebra here, not too bad. So here's our pi. We have our 0 to 4. We have our 16x squared minus x to the 4th, and we have the x here. Okay, again, the integrals aren't too bad. Again, what we're trying to do here, what I do? I put this in the wrong, I drew this in the wrong spot. So here, and we're drawing it around the x-axis, not the y-axis. So we're doing it this way. Okay? So again, we're kind of getting this giant little cone piece here, and we're taking away this little piece in the middle here. Okay, so it's going to look like a cone with like this little piece like this kind of filled out here. Okay, so that's what we're trying to do with this. All right. So sorry about confusing you guys with that one, but the idea here is like being able to see this. It's kind of tough to see it. I get that, but we're taking this little piece out here, and we've got this little like wedge-shaped thing kind of drilled out of it. Okay, but this is what we're doing with it next. Okay, time to integrate. So we have our pi. We don't need the integral sign anymore because we're going to integrate. So we have 16 over 3 x cubed minus 1/5 x to the 5th from 0 to 4. Okay, and that's where we are with that. Okay, so we just did the power rule. That's all we really needed to do. And now we have to do the hard part, which is the arithmetic. Okay, so we're going to be able to say that we have pi. Here we go. 16 over 3 times 4 cubed minus 1/5, 4 to the 5th. Okay, you guys are definitely allowed to use calculators. I won't bring up mine because mine is a really fancy calculator, but all the things I would use for my fancy calculator, you guys will have with the scientific calculators. They just won't be able to graph for you. So I would like you guys to graph these kinds of things, realize what's going on here, take your little dx pieces here so I can see what the cone is, because later on we're going to have different techniques to do different things. Okay, so there's a reason why we need to do this. So this is going to be 16, 4 cubed, that's going to be 64, all over 3, minus 1/5. 4 to the 5th is the same as 2 squared raised to the 5th power. Everybody should know that 2 to the 10th is equal to 1024. So this is going to be 1024 over 5. I know that 16 times 64, you guys can check me. This is also 1024 over 3 minus 1024 over 5, all times pi. I'm going to go ahead and factor this out. So we have 1024 pi times 1/3 minus 1/5. And then we can go ahead and figure out what's going to happen here. So we have a 3 and a 3. We have a 5 and a 5. So we have 5/15 minus 3/15. We have 1024 pi times, we have 5 minus 3. I'm going to call this 2 over 15. Okay, so let's see. If I multiply this, I double this piece here, that's going to be 2048 pi all over 15. And that is my volume for this little piece here. Yeah, and that's what we're trying to do with this thing. Okay. All right. Let's see. Next problem. So what we're going to try to do now is we're going to be given that we want to find the volume, calculate the volume of revolution. Okay. Constrained by, bounded by, we can say it that way. Y is equal to e to the x okay, from x equals -2 to x equals +2. Okay, about the x-axis, or about the x-axis. Let's go ahead and draw ourselves a little picture. Okay, remembering what the graph of e to the x looks like. It looks something like this. Okay, now we're going to go from -2 to +2. So we're looking at this little piece here. So it looks kind of like a funnel. Okay, that's what we can say that this thing would be kind of like, is with some kind of a funnel. And this is the kind of shape that we're trying to figure out here. All right. So we're going to set this up. So again, right, we're revolving about the x-axis. So this is my axis of revolution. So we're taking this radius and revolving it around the x-axis. So we're going to go from -2 to +2. We have a pi, and now we have an e to the x squared dx. You have to remember your rules of exponents. So we have an exponent raised to an exponent, we multiply the exponent. So this is going to be -2 to 2 of e to the 2x dx. All right. And we have to go ahead and figure out how to integrate this. So if you remember the formula, that's great. If it's been a couple of weeks since the semester you've had calculus, we're going to go ahead and we're going to do a tiny u substitution. So we're going to say let u equals 2x, du equals 2dx. Okay. So what I'm going to do here is, in order to be able to integrate this thing, we could say, oh, we could do one more thing. So when x equals -2, u is equal to 2 times -2, which is -4. When x equals 2, u equals 2 times 2, because x is 2 times 2, equals 4. Okay, so we could change everything into our u world, so rather than worrying about our x world. Doesn't really matter, but we'll go ahead and change everything to our u world. So our u's are going to go from -4 to +4. Okay, here's what we're going to have here. We have e to the 2x. I let my u equal 2x. So we have e to the u. Okay, now I would like a 2dx in order to substitute. So what I have here is I haven't changed my dx yet. I'm going to multiply by 2, but I can't go around multiplying stuff by 2. That's not fair. I'd love to multiply my bank account by 2. That would be great. Can't do that. You have to multiply by 1. So if I'm going to multiply this piece by 2, I got to put a 1/2 out in here. Now this piece here is now my du. So this is going to be 1/2 integral -4 to +4 e to the u du. That's a physics integral is what that is. That's an easy integral. So we have 1/2 integrate e to the u. We just get e to the u going from -4 to +4. Oh, there's a pi out here. Okay, I forgot there's a pi out here. There's a pi out here. And well, there's a pi out here. Okay. So going from -4 to +4, we have pi over 2 times, and here we have e to the 4th minus e to the -4th. Okay, it's a fraction. That's a small number. Okay, but that would be my volume for this particular idea here. Okay, and that's the kind of thing that you're looking to do. And that's what these are going to look like. All right, so we would have that. Okay, so we can say that thing right there. Okay, okay, let's do a different one. Okay, so we're just plugging along here with doing some problems. And what I want to say is we want to find the volume of revolution. Okay, defined by or constrained by x equals the square root of 6 minus y. Let's see here. From y equals 0, we'll say y equals 0, x equals 0. Okay, about the y-axis. Okay, go ahead and write that down in English so we know what the heck we're doing here. But we're going to be going around the y-axis. Okay, we still have to draw this thing. Okay, so the first thing we have to do is figure out what's going on here. So I'm going to go ahead and draw this thing here. It's my x, here's my y. So as I'm thinking about what's going on here, right? If, let's see, we'll say this. If x equals, or if y equals 0, it's going to be down here. Okay, my x value is going to be the square root of 6. Well, I know the square root of 6 is like 2 point something, right? I've got like a little calculator here. We could calculate this out. We could say 6 square roots, and we get 4.49, 2.449. Okay, so we're going to say 1, 2, 3. It's going to be out here somewhere. Okay, so when y equals 0, which is down here, this is y equals 0, our x value is 2.249. Okay. How about when, let's see, we're going to say when y is equal to 6. 1, 2, 3, 4, 5, 6. Right? So when y equals 6, yeah, when y equals 6, we have x is equal to 0. So we have 6 minus 6. Square root of 6 minus 6 is going to be 0. So my x value is going to be 0. Okay, so we have this. So y is equal to 6, x is equal to 0. Okay, how about when y is equal to 1? That's going to be right here. So we have 6 minus 1 is 5. We go ahead and take the square root of 5. We get 2.25-ish. So we're going to be over here somewhere. Okay, so that's y equals 1. How about when y equals 2? When y equals 2, that's going to be this point right here. We have 6 minus 2, which is 4. Take the square root of 4. We're going to end up here at 2. Okay, so we're going to end up with a graph that's going to look like this. We'll pretend that we were better at connecting, placing the dots. Okay, but we're going to end up with something like this. And we're going to, again, we want to revolve around the y-axis. So here's the little slices that I'm taking. So here are my little dy's that we're going to go ahead and deal with this. All right. So let's go ahead and integrate this piece. So we have pi. Here's my 6 minus y. Now we still have to square my radius, dy. Okay. And it looks like this is going to go from 0 to 6 as far as y goes. Okay. So we're going to go from 0 to 6 as far as y is concerned. Okay. Let's go ahead and square it. It's a square, we're squaring a square root here. So we're going to say this is going to be pi, and we have our integral from 0 to 6. This is just going to be 6 minus y dy, right? And now we're ready to go with this. So we're going to say we have, let's see here, we've already squared it. So we know we have pi. Now we're going to integrate. So we have our 6y minus 1/2 y squared, and we went from 0 to 6. Okay. And that's what we're going to go ahead and figure this out for. So we plug in the 6, we have pi. Here we go. We have 6 times 6 minus 1/2 times 6 squared. Okay. Minus, now I'm going to plug in 0, 0. Right? All of that is 0 when I plug in 0. That's not always going to be the case, but it frequently is. Okay. So we have here, we have our pi. We have 6 times 6 is 36 minus 1/2 of 6 squared, 1/2 of 36 is going to be 18. So we have 36 minus 18, which is going to give us 18 pi. And that is the volume of that solid that we have for sitting on this piece right here. Okay, so I think that's long enough to do all of this stuff. So I'm going to say to you that it's important to practice this stuff. So try to practice drawing it so that'll get your graphic back in shape a little bit. So just try to remember that the pieces that you have to be, when we're revolving, try to make sure that we're revolving a perpendicular piece to your axis of revolution. Okay, so we can sum up all of our little D parts of it. Here, do this. Okay, I will be back in another video to show you some more, but thank you very much for watching, and I will see you in the next video. Take care.